In this video, I will go over some examples that are pre-calculus algebra topics, and these are what I'm going to call quadratic-like equations, or other types of equations. These are equations that you can solve with similar methods to how you'd solve quadratics. Here's an example. Or let me also add to that, or other equations that will require solving a quadratic at some point. Here we have two radicals. As if one radical wasn't enough, we have two. And to solve this example, what we're going to do is isolate one radical, square both sides, isolate, and that's going to eliminate one of the radicals, and then isolate the radical again, square both sides. Some students don't have the stamina to finish this question, but you can do it. You just have to keep going. You can't stop midway. Just keep on that path. Remember that the goal is to solve for x. If you tried squaring both sides as it is with two radicals, you'd see that you still get a radical in your equation. So the only thing, and it gets really complicated also, so not advised. What we want to do instead is isolate one of them. So I'm going to add the square root of x minus 8 to both sides. And then when I have the square root of x minus 5 isolated, I can square both sides. So I'll square and square. The square of a square root is just going to give me the radicand, the x minus 5. And then on the right, now I'm going to use a pattern. You could use FOIL, but you could also use this pattern. It's handy to pull out of your toolbox. The quantity of a plus b quantity squared, so a binomial sum squared. You can FOIL it. You get a squared plus the inside times inside, and the outside times outside is going to give you ab twice, so they add together to 2ab. So it works out to this pattern. And this pattern is helpful to use when approaching a complicated example like this. So I'm going to have this 3 squared. Let me write this out using the same color first. Then twice the x minus 8, and then the square root of x minus 8 squared. So the first term squared plus twice the second term plus the last term squared. When I simplify that, 3 squared is 9. 2 square root of x minus 8 doesn't do anything, but here you can see that we've eliminated one of the square roots because the square of a square root gives us the radicand. So we just get the x minus 8. Now we're going to isolate the radical again. It's right here. So we're going to subtract the x. Actually, before I do that, just to make this a little simpler, I could take this 9 minus 8 and simplify that to be 1. 9 minus 8 is 1. But I'm going to subtract x from both sides. I'm going to subtract 1 from both sides. And I'm going to get negative 6 equals 2 square root of x minus 8. Divide by 2 to further isolate that radical. And I have negative 3 equals square root of x minus 8. Now that I've isolated, what I'm going to do is square both sides again. And you might notice a problem. I'm going to ignore the problem and come back to it. Just to show you what happens. When I square both sides, I get -3 squared is 9. Square of the square root is the radicand. And now if I add 8 to both sides, ta-da, I've got x equals 17. Well, I need to check that, because radical equations can sometimes have some strange results. So I'm going to check this by putting the 17 and look at what happens. I get just all kinds of craziness. Square root of 12 minus square root of 9 equals 3. Square root of 12 minus 3 equals 3. Well, if I add that 3 to both sides, 12 does not equal, square root of 12 does not equal 6. So I can see that this x equals 17 is a extraneous solution. And the answer to this problem is that there is no solution. I could write that like this, meaning the empty set. I said that I was ignoring a problem. Let's go back to that, because in the future you might find your problem before you go through all of that havoc. Do you see this? I'm going to erase some of the extra stuff. Before I squared both sides, I had this. Can you see that? I had -3 equals the square root of x minus 8. Do you see the red flag there? The radical cannot equal, a square root cannot equal a negative. So right here at this step, I might have noticed, oh, this problem has no solution. When you see that, you could stop as you go and say, oh, no solution there. All right, let's try another example, number 3. Solve 6 times x to the 5 halves minus 12. I'm going to remember that x to the 5 halves means x to the 5th and then square rooted. Do you see where that comes from? This 2 in the denominator becomes the index of the radical, and the 5 sticks to the x. The 5 sticks to the x. So this x to the 5 halves is the same thing as x to the 5th square rooted. What I'm going to do to approach this is I'm going to start by isolating the x term. So I'm going to divide, oh, I'm sorry, not divide yet. I'm going to start by adding 12 to both sides. So 6x to the 5 halves equals 12. And then I'm going to divide both sides by 6. 6 divided by 6 is 1, so I've got x to the 5 halves equals 2. And now, to isolate this x, to solve for x, I'm going to raise this to the 2/5 power. Because do you see what happens if I multiply 5 halves times 2/5? I get 5 times 2 is 10. 2 times 5 is 10. So that's 1. 10 over 10 is 1. So the way I can undo this 5 halves is to raise it to the 2/5, and they undo each other. Now if I'm going to raise the left side to 5 halves, or to 2/5, I've got to do the same to the right side. So on the left, we just have x, and on the right, we have 2 squared 5th rooted, or 2 to the 2/5. So the 5th root of 4, which it doesn't simplify. So I could write the answer, the 5th root of 4, or I could write the answer 2 to the 2/5. Either way would be acceptable. Let's try another example. In this next example, we're going to see something very similar. Expression now raised to the 2/3. We'll approach it the same way, meaning I'm going to recognize that 2/3 times 3 halves is equal to 1. So what I'll do is I'll raise both sides to 3 halves. X minus 4 to the 2/3 raised to the 3 halves. And then 16 raised to the 3 halves. X minus 4 to the 2/3 to the 3 halves equals the square root of 16 cubed. Now, be really careful here, because do you see what I'm doing when I raise something to the squared power, or to the half power rather? Let me show you this just to make sure you're recognizing this. You could see this x minus 4 to the 2/3 as x minus 4 squared cube rooted. But when I do this to the 3 halves, what I'm doing is cubing it, but then watch this. I'm using the square root property. I'm taking an even radical, an even root to both sides. Do you remember that extra step? I know it might be hard to remember this every time. But when this denominator, when I'm raising both sides to a fractional exponent, where that denominator is even, it's like doing the square root or 4th root or even root of both sides. And we have to be mindful at that point that there's 2 solutions, a positive or a negative version. So watch out for that. Okay, let's continue here. We've got x minus 4 equals the positive or negative square root of 16 cubed. I'm going to add 4 to both sides, and I've got x equals 4 plus or minus the square root of 16 cubed. I'm going to write that 16 cubed out expanded so that you can see what I'm doing here. The square root of 16 times 16, I can remove one of those 16s, right? And then I have the square root of 16 is 4. So I have that's cube of 16 square rooted is equivalent to 16 times 4. So I've got x equals 4 plus or minus 64. And I don't want to leave it like that. I'm going to do 4 plus 64 and 4 minus 64. So that's 68 and 60. And I'm going to put them in order, smallest to biggest. So I end up with the solution set of 60 and 68. Are you ready for just a couple more examples? This next example is a quadratic like. It's not quadratic because it's to the 4th power. You could use what we see over here, what we call u substitution, and think of it like let u be x squared, and if u is x squared, then u squared is x squared squared, or x to the 4th. So that would give us, this equation would look like this. X to the 4th is u squared. X squared is u. So it's just this example. This is pretty easy to solve at this point. I'm using factoring. So I mean easy to solve as in compared to some of the other things we're doing, right? So u minus 4 times u minus 1 equals 0. If I FOIL that, I can check that I get u squared minus 4u minus 1 more u is minus 5u plus negative 4 times negative 1 is positive 4. And then the last step is I've got to set each factor to 0 and solve for u. So it looks like the solution is 1 and 4. But wait, that can be deceiving, can't it? Because what did this question ask us to solve for? For x. So don't be too quick to box your answer and call it done. We need to take these u's, the 4 and 1, and go back to our substitution. If u is substituting for x squared, then we have 4 is x squared, and we still need to solve for x. We can do the square root of both sides using the square root property. It'd be square root of x squared is plus or minus square root of 4. So x is plus or minus 2. And then the same thing with the negative 1. If u is x squared, then 1 is x squared. Doing the square root of both sides, we'd get x is plus or minus 1. So the solution set would look like this: negative 2, negative 1, 1 and 2. Now that's one way to do it. Let me show you one other way. I have a hard time saying which one I'm going to deem easiest. I don't know that there's an easier of the two, but one way of doing it is to just take our x to the 4th minus 5x squared plus 4. If you're comfortable enough with the factoring, you could just factor that straight away. It would be x squared minus 4 no, just minus 4, sorry. X squared minus 4 times x squared minus 1. And if you use the FOIL, first times first is x to the 4th minus 4x squared minus 1x squared simplifies to minus 5x squared. Negative 4 times negative 1 is plus 4. And then we're back to the same place, because when we solve each of these factors set to 0, we'd get the same result. So this method, the green method you see on the right, might work for some if you feel really comfortable with the factoring. This next one, similarly, but I don't know about factoring this one. I think you might be able to factor this, but probably almost everyone would see this to be a little easier just doing the substitution. So when I'm substituting, I'm letting u equal the variable in the middle here. So u is going to be x to the 1/3. If u is x to the 1/3, then u squared is going to be x to the 1/3 squared, or x to the 2/3. So I'd have u squared minus u minus 6 equals 0, factoring u minus 3, u minus 2. You could check that with FOIL. U minus 3 is 0, or u minus 2 is 0. U is 3, or u is 2. So if u is equal to 3, then x to the 1/3 is equal to 3, or x to the 1/3 is equal to 2. Please pardon me with this cough. Had COVID a month ago and just not able to shake this cough, so I apologize for that. How do we simplify this something to the 1/3? Raise it to the 3rd power. So we'd have x to the 1/3 to the 3rd is just x. 3 cubed is 27. X to the 1/3 cubed is x. So x equals 8. So it looks like the final answer here is going to be almost, oh wait, I'm sorry, I'm looking over this and realizing we're almost there. But did you notice this when I factored it? And I said foiling worked out, but negative 3 times negative 2 would give us negative 6, and we wanted a positive 6. So this one actually has to be a positive, making this positive, making this negative. I knew something wasn't quite right, but this negative 2 cubed is going to be negative 8. Okay. If I didn't lose you there, if you need to, pause the video, go back, and look at that again. Number 5, last one, absolute value. To solve an absolute value. Now, this might feel a little challenging, but look at this on the other side when we have this example. That the step we're going to take is we rewrite this where the thing that's inside the absolute value, the x minus 2, that piece inside that absolute value, it might be 7, or it might be the opposite of 7, right? Because if it were the opposite of 7, that piece inside this x minus 2 could be the opposite of 7, and when we do the absolute value, we'd still get the positive 7. So we have x minus 2 is either equal to 7 or the opposite of 7. And then solving for x, we're going to add 2 to both sides to get 9. Add 2 to both sides to get negative 5. And the solution is negative 5 or 9. Well, I hope that this video has helped you work through these problems. I'm going to skip this number 6 for now because the video's gotten so long. But if you have questions about that number 6, we could go over that one in class. Please let me know if you have questions about any of the examples in the video. We'll always start class with time for questions.